Hey everyone, back again. As you've seen on the title, this is a video about understanding amperage and wire size in regards to the amount of amperage load that you have in electrical. I want to get something out of the way immediately because this video could be a little bit controversial as far as electricians are concerned, professional certified electricians. I'm not trying to tell you to go do any electrical in your shop or your home on your own. Obviously it's very dangerous. You could kill yourself, you could burn down your home, you can run into all kinds of problems. This video is solely to just help you understand it a little bit better. Okay, it's not to encourage you to go out and do it yourself. Some of us, like myself, I do things myself, but that's a risk I choose to take, and I'm not going to encourage you to take that same risk. So, before you do any kind of electrical work in your home, at the very least, consult a certified electrician and make sure that you're doing it properly if you choose to do it yourself. Preferably just hire a certified electrician to do the work, this way you know it's done properly. Okay, with that being said, oh, one other thing. For any certified electricians that may be looking at this video, if by some small chance that I give out some misinformation, be respectful, but please do, comment below. Let me know what I made a mistake on. I will definitely edit the video and add an annotation to correct any mistakes that I had made. I don't think that I'm pretty positive that I'm not going to give out any false information, but just in case. So, with that being said, let's get to what I'm here to show you. Okay, so this is what we have here. I have a basic drawing. Let's go through the elements real quick. We have our circuit breaker box. We have a dedicated 210 volts line rated at 50 amps at the breaker. The cable running from the breaker to the outlet is rated for 50 amps. And we have our outlet that's rated at 50 amps. On this side we have 110 volts. Breaker's rated at 20 amps, the line is rated at 20 amps, and our outlets are rated at 20 amps. Okay, now with that being said, kind of ignore this just for a quick second, and let's talk about voltage and amperage. To give you a basic idea of how voltage and amperage works would be to kind of say it like this. Voltage is force-fed. Okay, if I plug in a lamp to a 110 volt outlet, it's going to be force fed 110 volts whether it likes it or not. Okay? If I plug in my cell phone to 110 volt outlet, it's going to be force fed 110 volts even if it doesn't require it, which cell phones don't. So this is where you would have something like this little cube right here. And they don't all look like this. Sometimes it's a bigger box type thing with your plug prongs coming out of it. We've all seen stuff like that. Or sometimes you'll have a regular plug, you'll have a line, a big box, and then another line that goes into the device. They all do the same thing. Essentially what those are doing is they're dropping the voltage coming into the device. So because the outlet is trying to force feed you 110 volts, that little cube right there is knocking it down to whatever the device actually needs. And that is a necessary thing, because if it didn't have that, I'd blow up my cell phone when I plugged it in. and probably literally, because it's charging the battery. The battery is only able to handle a certain amount of power. It could literally make the thing kind of blow up on you. So, with that being said, now that you understand what voltage is, it's something that's being force-fed. Amperage is essentially just the opposite. Amperage is drawn out of. I have 20 amps available, but the device may only draw 10 amps. It's taking what it needs and leaving the rest behind. Okay, so in this situation here, we have a 50 amp breaker. We have a line rated for 50 amps. We have an outlet rated for 50 amps. Well, we have a welder here that's rated at 35 amps. 35 amp draw. That doesn't mean that this does not work here. Okay, the welder dictates how much it needs. The welder looks over here and says, I need you to give me 35 amps, send 35 amps down this line and all the way over here to my welder so that I can operate correctly. It's not going to take 40, it's not going to take 45, it's not going to take 50, it's going to take the 35 amps that it needs. Okay, so you're not going to have 50 amps flowing through here because it doesn't need it. If I plugged in, let's say, I don't know what's rated at 50 amps, but let's say I had an AC unit that was rated at 50 amps, and I plug it in here. That AC unit's telling this, I need everything you got. I need all 50 amps. I'm taking all of it. And you're fine, because everything is set up to be able to handle the amperage flow. Okay, and now let me get to why I'm making this video. I did a video where I was installing this 50 amp rated plug onto my Everlast PowerTIG 210 EXT TIG welder. One of the people that was watching the video saw the cable coming out of the welder was a smaller gauge wire. And he was concerned that if I plugged this into a 50 amp plug, or 50 amp outlet, that I was going to burn up my machine or cause some sort of electrical problems in my shop or something like that. And I truly appreciate his concern and trying to look out for me, but he's wrong. Okay? And he's wrong because the welder dictates the amperage flow. The 50 amps are available, the welder says I don't need it all. That's why that wire is so thin. That's why it's a smaller gauge wire, because this is something the manufacturer has set up and is a requirement by U.S. law that their cable matches the amperage requirement of the machine, so that this way this cable can handle the amperage flow that this machine will draw at a maximum. The plug doesn't do anything, the outlet doesn't do anything, and just because I have 50 amps available at my outlet doesn't mean that 50 amps are going to flow through there. Okay, now that we fully understand that, let's look back at this drawing. Where the wire gauge is most important, if I have a 50 amp plug or 50 amp outlet, is between here and here. If I have a 50 amp breaker and I have a 50 amp outlet, and I have a wire running from the outlet to the breaker that is only rated for, let's say, 30 amps, and I run a 35 amp welder, I've got a big problem on my hands. The wire here is going to heat up. Okay, my breaker is never going to pop. Okay, it's never going to pop the breaker because the breaker can handle the 35 amps that this is requiring, but this wire here is not able to handle it. So it's going to heat up and potentially cause a fire. Start melting the casing, potentially cause a short and a fire, and we got serious problems on our hands. And we've all, let me see, we've all encountered situations where we've touched something that was charging and it's gotten hot. Maybe for those of us that work in shops, maybe we went and got an extension cord, a really thin extension cord that we really shouldn't be using in our shop, that is not rated at the amperage that we're trying to run through the cord, and the cord starts to get hot. That's why, okay? That's what's happening. You're exceeding the amperage limits of the wire. And just because your breaker and your outlet are able to handle it doesn't mean your wire is able to handle it. So that's why it's important to make sure your breaker, your wire running from the breaker to the outlet, and your outlet are rated at the same amperage capacity. The wire running from the outlet to the machine doesn't matter. As long as you didn't install this wire, it doesn't matter. Okay, if you were trying to do some of your own home electrical BS on a welder that you got off Craigslist or something, you need to find out what the amperage draw is for this welder and make sure that the gauge of wire going from the welder to the outlet is proper. But I would highly recommend that you don't do stuff like that unless you are a trained electrician. So, Now you basically understand why this video is being made. I'm going to talk about this part right here real quick, and this is what you're going to find typically in your house or like here in my shop. You're normally not going to find a 20 amp max rating in your house. Okay, normally what you're going to find is a 15 amp breaker, 14 gauge wire which is rated at 15 amps, and you're going to find 15 amp outlets. Okay, this is a 20 amp outlet. Looks real similar to a 15 amp with the exception of this little T that's right here. 15 amps looks like this, 20 amps looks like that. 20 amps is actually just a horizontal prong. It's not a T-shaped prong. But this outlet will work with both because, again, there's no problem running a lower amperage off of an electrical outlet that can support a higher amperage. Okay, this outlet and this line is set up for 20 amps. I can plug in a 15 amp device and it'll be fine as long as it's 110 volts. Okay, however, most of us, and I would be willing to bet all of us, have plugged in too many devices into one particular breaker. Not one outlet, because you got multiple outlets. In this case, we got 3 outlets that are going to one breaker. In this particular case, the maximum amperage for all 3 combined is going to be 20 amps. It's not 20 amps plus 20 amps plus 20 amps. It's 20 amps divided by 3. And not even really divided by 3. It's this device plus this device plus this device cannot exceed 20 amps. Okay, if you exceed 20 amps, you're going to trip your breaker, and hopefully your breaker, your wire going from the breaker to the outlet, and your outlet is all rated at the 20 amps, because then your breaker can do its job and pop before you start having a meltdown here at your outlet or at the cable that's running to the outlet. So that's a basic understanding of how amperage works, and I hope it's helped some of you guys out. And again, you know, this is not to encourage your do-it-yourselfer to start messing with the electrical in their home. This is to just try to help you understand it a little bit better. Everybody at some point, all of us do-it-yourselfers have probably at one point considered or have tampered with electrical in our homes or our shops, whether if it's changing a light switch or changing an outlet. A lot of us have done that, and that's fine. That's something easy that your do-it-yourselfer can do, but if you're a first-timer with dealing with electrical in any form or fashion, contact a licensed electrician, at the very least, to just get some advice from them. Don't look at YouTube and read crap on the internet and just jump into doing something, because if you got the wrong information, you could have a serious problem on your hands. Make sure that somebody that is licensed and trained is giving you the proper information that you need. I am not that person, so take the information I'm giving you and take it with a grain of salt and just use it to help you try to understand this a little bit better. Okay? Thanks for watching. Subscribe, comment, like. Check out alvarezmetalworks.com in the description. That's my website. Go like my Facebook page. The link is on my channel homepage or on my website, at the top of my website. If you're viewing this video on Alvarez Metalworks, go subscribe to my YouTube channel. That would be awesome. Alright, thanks for watching. I hope this has helped you out, and talk to you later.